This is 1.8, solving different types of inequality stuff you've probably never done before. So what we're looking in here, notice this is a bigger polynomial. This is x squared, okay? Or I might have x cubed, or whatever the polynomial is. And notice it's an inequality where I want to know where x squared minus x minus 6 is less than 0. So there's two ways to do this. So let me show you both ways, and then you choose whichever way you prefer, and it's a good double check method to know both ways. So just for a moment, pretend that this is equal 0, and then of course factor. So this would be x minus 3 and x plus 2. And then when you set this equal to 0, you're going to get x equals 3 and x equals negative 2. And you're like, well, is that my answer? Well, remember, we're trying to find out when this polynomial will be less than 0. And so what we want to do is think of a number line. Think of these numbers that we just found, negative 2 and 3. And what we're interested is, notice the interval. So we have this interval here, from all the way from negative infinity all the way to negative 2, all of those numbers. We have this interval from negative 2 to 3. And then we also have this interval here from 3 to infinity, all the numbers that way. And so what we're going to do is we're going to test these numbers and see if they actually are going to fit into the inequality. So we're just going to pick numbers from each category. So if I choose a number over here, pick any number over there. Let's say negative 3. So if I pick negative 3 and I plug them into this polynomial, the easiest way is right here. So if I put negative 3 into this parenthesis and negative 3 into that parenthesis, so I'm going to get negative 6 and negative 1. If I multiply that together, that's positive 6. And positive 6, is that less than 0? No, it's not. So this interval, those numbers, I could test another number, but those numbers over there will not work. And so we're going to test each of those sections to see which one will work. And it could be more than one interval, by the way, so we're going to check them all to make sure. So let's try a number in here. I'm going to choose 0. And so if I choose 0, put 0 in for the x. So I'm going to get negative 3 and put 0 right there. I'm going to get 2. When I multiply together, that's negative 6. And negative 6 is less than 0. So this section works. If I try a number over here, so I'm going to try the number 4. Or 5 or 6, whatever number you want, but I'm just going to choose 4. So if I choose 4 right here for x's, I'm going to get positive 1, and I'm going to get 6. I multiply that together, that's 6. 6 is less than 0, that's false, so those numbers will not work. So only the numbers in between here will actually work, from negative 2 to 3. So that is literally my answer, negative 2 to 3 will work. So any number in that interval will work. Now that's one way to do it, okay? Just by factoring and then testing the numbers in between all of those categories. The other way to do it is if you grab your calculator and actually plug this in. So x squared minus x minus 6. And if I push graph, so what I'm looking for, notice I'm trying to find out where will this be less than 0. So in other words, look at the graph and notice the graph. Oops, let me back that up. Notice the graph, negative 2 and at 3, those are my zeros. Remember, I found my zeros, those are my zeros. And I know the parabola goes up. You don't really need a graphic calculator, by the way. As soon as you factored it, you could literally just graph it in your head because you knew that parabola goes up. But notice we want to find out where it will be less than 0. So notice this, you can see it on the graph, it's less than 0, below the x line. And it's between negative 2 and 3. So using the graph sometimes is even quicker. So I showed you both methods, and it's a good way to check them using both methods. So let's look at this one. So we have 4x squared minus 5x is greater than 6. So we're going to bring everything over to one side. And what we're going to do is similar to the last one, is we're just going to test these numbers to be able to, factor it or graph it whichever way you want. So if you factor this, you're going to end up getting x minus 2 and 4x plus 3. Set this equal to 0, and that's going to be 2. And set this equal to 0, and you're going to get negative 3/4. So you can, again, doing the number line, you're going to look at negative 3/4, and you're going to look at 2, and then just test some number over here like negative 1. Test some number over here like 0, and then test some number over here like 3. And then see if it's greater than 0. Okay, that's what you want to do. Just test it. So if I put negative 1 in here, I'm going to get negative 1 minus 2 is negative 3. And put negative 1 right here, you're going to get negative 4 plus 3 is negative 1. And then multiply that, that's positive 3, and 3 is greater than 0. So this section right here does work. Now, if I try another number, this middle section, 0, if I put 0 into those spots, you're going to get a negative number, and you're going to get a positive number, which is going to give me a negative 6, and that's not greater than 0, so this section does not work. And then we're going to try this section right here. If I put 3 in, I'm going to get 1, and put 3 in, I'm going to get 15. And notice when I multiply that together, it's greater than 0, so this section works as well. So both of those sections will work. So literally negative infinity all the way to negative 3/4 will work. But so will 3 all the way to infinity. All right, so the other way to do it again is if you take your calculator and graph this. Again, you don't need a calculator, but because we already factored it, okay? So we know that at 2, and we know at negative 3/4, and we know it's positive. So we know the parabola is going to go like that. And we simply want to know when it will be above 0. Well, it's going to be above 0 those two spots. So from negative infinity to negative 3/4, and from 3 to infinity. I said 3. That's actually 2. We found that the 0 is 2. 2. All right. So that's how you can use it graphing or by the factoring method. Either one will work. So let's consider a problem like this. So if we had this problem to solve this, again, we want to set it equal to 0. So we're going to bring the 3 over. And something I want you to get in the habit of noticing right at the very, very beginning. Notice x on the bottom. So that cannot be 5. If x was 5, then we would have 0 on the bottom, and 0 on the bottom of a fraction is undefined. So x cannot be 5. That's something we got to consider. So when we draw the number line, 5 is one of the numbers that we're going to consider. All right, so that's something you have to notice right off the bat. All right, so we have less than 0. Now we're going to get a common denominator, which is x minus 5. And we're going to multiply this by x minus 5 over x minus 5 to get that. So that's 2x minus 7. Use the distributive property with a negative. And that's going to give me negative x plus 8 over x minus 5. And so basically, we know this can't be 5. Okay, we know that can't be 5. X cannot be 5. And then notice, because it says less than or equal to 0, it could equal 0. And the only way it could equal 0 is if the top is 0. So in other words, x would be 8. If this was 8, then that would give me 0. So we need to also consider 8 on the number line as well. So if you look at this, we're looking at numbers over here, we're looking at numbers in between there, and we're looking at inside or outside of that as well. So you're just going to have to consider each one of these. Again, pick a number over here like 0, pick a number in here like 6, and pick a number over here like 9. And then try those numbers and see if they actually work. So just to conclude, notice I found from negative infinity to 5 works. Also 8 to infinity works. I do want to point out to you that because this says less than or equal to, that's why we have to include the 8. Does actually work. This interval does work, but because it says less than or equal to, we put a bracket. Now we can't include 5. Remember, it cannot equal 5, so that's why we put the parenthesis on 5.